This meeting is being recorded.
In sample exercise 8, we're asked to calculate the pH of a few points along this titration here. So we're given the information here. We have 20 milliliters of a 0.5 molar hydrochloric acid, and then we're going to titrate with 0.5 molar sodium hydroxide. So we're given the volumes at each point down here, but in the first portion, we're going to solve for the pH before the addition of any sodium hydroxide. So let's set up our calculation here. We know with, in this case, we have a strong acid being titrated with a strong base. Our pH at the equivalence point should be right around 7. So we can make a note of that. pH at equivalence point should be equal to 7.00. And when we have an acid, the concentration of hydronium ions will be equal to the concentration of the acid because it ionizes 100%. So we know that we have concentration of hydronium of 0.500. So we're going to take that value, plug this into the negative log expression. So we'll see what that is. Our pH will be fairly low, about, or very low really, about 0.301 when we plug that in to the log expression. All right, so that's our starting point before we add any base. So we should expect our pH to increase at this point here. So now we're going to add 10 milliliters of the same concentration, 0.5 molar sodium hydroxide to our 20 milliliters of 0.5 molar HCl. So in this step, we're going to calculate moles of acid, and that's going to be this value here. Oh, so we have 0.5 molar times 0.02 liters. So again, I converted that to liters from milliliters, and this tells me that I have 0.01 moles of acid. And then I can do the same thing with my base. So I have added to 0.5 molar 10 milliliters, so 0.01 liters. So now I have 0.005 moles of base. All right, so at this point, what would happen? We can write out our general equation that would occur. So we have HCl, we titrate with sodium hydroxide. We began with 0.01 mole here. We begin with 0.005 moles here. Whichever is least, that will get all used up. So our sodium hydroxide, that's all gone. We subtract that from our HCl, and we see our concentration decrease to 0.005 molar for our HCl. Now, to find the, that's how many moles we have, rather. So we have 0.005 moles of hydrochloric acid, and this is now in a total volume of 30 milliliters, 0.03 liters. So if we plug this in, our concentration of hydronium at this point that we can plug into our negative log expression would be equal to 0.167 molar. So now when I take the negative log of that, I'm still going to have a fairly low pH, but now it's around 0.077. So we've gone from 0.3 up to 0.77. Let's take a look at what happens when we add 20 milliliters of the same concentration. So we'll do our mole calculation over here real quick. Moles of acid, moles of base. All right, so moles of acid will be the same, 0.01, because that's what we started with. That's all we have. Now we're going to add the same volume of base. So since it's the same concentration, we know that we're going to have the same amount of moles. So again, these are moles of acid, moles of base. So now in this scenario here, if we were to plug into our reaction equation here, if you will, we're going to have the same amounts. We're going to subtract the same amount, we get 0, etc. over here. So we're going to skip this calculation-wise because we know that at our equivalence point, our pH would have rapidly rose and actually become exactly, oh, where are we? 7.00 at the equivalence point. And we know this because it's a strong acid, strong base situation. All right, so now at 0.4, now we're going to see a little bit of excess base. So let's calculate our moles of acid will be the same, so we don't need to redo that. Now moles of base, we're going to have slightly more. This is going to be 0.0101. And I got that by multiplying my molarity, 0.5 molar, times my new volume, 0.0202 liters. All right, so now what do? We do the same thing as we've done previously. We find out the excess of sodium hydroxide here. So what do? We take our equation, HCl plus NaOH, and we have 0.01 minus all you can subtract here is 0.01. My base, I started with 0.1010, and now I'm sorry, 0.0101. Let's go back, or else the math will not look as good. There we go. So now we have 0.0101, and then I subtract all that acid. So my excess is this small amount, 0.0001. So 3 zeros and then a 1. So now I have my hydroxide ion concentration at this point because this is an excess. So now if I take the negative log of this, I'm going to get POH. So let's do that. I'm going to take again the negative log of my 0.0001. And we get our hydroxide ion concentration equal to 0.00249. We have to do one more thing here. After we plug this in, rather, I'm going to get my POH. There we go. So POH is equal to 2.6. And then to find pH, I'm going to squeeze this in here, in this small spot. We're going to do 14 minus 2.60. So my pH is going to be, I'll write it above, 11.40. So this is our final pH. Actually, let's write it up here. So we have everything nice and neat in a row.